All right. So we're going to go back to increasing and decreasing. We're going to do a lot more with it. Let F be continuous on the closed interval and differentiable on AB, the open interval. That's very stereotypical for any of our definitions. Those two things are the condition. Okay, remember when F prime is greater than 0, F is increasing. Remember that? Good. F prime is negative, F is decreasing. Okay? All right, we have two situations. This is not cut off here, by the way. This is F prime. Okay? And this is F. So these are two different problems. We can apply this and look for where F is increasing and where F is decreasing. Okay. So the language, you got to remember it. All right. Where is F prime positive? F prime is positive. Where's F prime positive? You are looking at F prime. Yeah?
When your y value is greater than 0.
Okay, so specifically that would be
that would be between
like here and here.
Yes.
Okay, does everybody get that piece? Okay, so we're going to have to guess. It looks like it's a little past negative 4-ish. Okay. So negative 4 to negative 1. And then again at 1, 2, 3.7 to infinity. Good job. Okay, so you've got to say the words to yourself. Okay, I'm looking at F prime. I'm looking at where this F prime is positive. All right, F is decreasing when F prime is negative. Let's do that. Oopsie. I need to do that. I'm going to do that in a different color. Green. All right. That's all this, this, and this. Okay? So F is negative. Where? We have to use the same point. So negative infinity to negative 4. Good job. And then again at negative 1 to 3.7. Whatever you chose to use it again, because otherwise that'd be weird. Okay? To get that piece. All right, very good. So that's that. Let's do the one where we don't have a graph. I'm not going to have a calculator to make a graph, so I'm going to find F prime. I feel like we've done this a fair amount. I don't know what section it was in. All right, so who can give me F prime? Thank you, Emma. Very good. Okay. Now, if we are going to want to know where F is increasing, or sorry, where F prime is positive, what are we going to have to do next? Interval test, so we're going to have to equal 0 first. Get some critical numbers. Is this factor hopefully? Yeah. There's a 2, there's a 1, there's a last one. Yeah. It's a beautiful thing when it factors, right? What are my critical numbers? 2 and negative 1/3. Okay, so critical numbers. Now I can use that. We need an interval test. Negative 1/3 is here. 2 is somewhere over here. Now, you can spend the time to plug in, but there's a more efficient way because you know quite a bit about this quadratic graph. Okay? It's going to be like this. Right? It's going to open up because of that positive 3. There's your roots. So F prime over here is going to be positive. It's that up above, like this blue was. then it's going to be negative, then it's going to be positive. So you can't always use that, but if you can use it on the quadratics, it saves you a little time than plugging in 3 different numbers. Okay, so on this problem, f is increasing where, Miss Emily?
From negative to infinity to 100, and then from 2 to infinity.
Nice. Okay. And f is decreasing. Kathleen? Okay. Now, we talked about earlier, any questions on increasing, decreasing? Rerun, right? Okay. What's in between, what's right here? What would you call that? It's a local something. Remember when the f prime changes from negative to positive, what is that? Then, what's this one? Now we went from positive to negative, so that's a local max, and then we turned again over here from negative to positive, local min again. Okay? That's what the next page is about. We never called it the first derivative test again, but basically we find f to be a continuous function, and we have c being a critical point, which means to find a critical point we had to find the f prime, first derivative. If f prime changes sign from positive to negative, then f has a what at that moment? Local max. Okay? F prime changes sign from negative to positive at that critical number c, then f has a local min at c. If f does not change signs, then there is no local extreme, or let's just write local max or min. Okay, and sometimes it doesn't change, it depends on your graph, your function. Sometimes it does this, it bounces. So right here, there would be no local max or min because it doesn't change. It goes to 0, but then it bounces back up. Okay, the multiplicity and all that, remember that from pre-calc. All right, any questions about that? You just kind of have to remember it. This is a positive slope, this is a negative. You would never, if you do that visually, you would never think, oh wait, that's a negative. That's a max. That's a min. All right, so go ahead and look silly, but it's better to look silly and do it right. Okay, concavity again. We have concave up, we have concave down. And we've done concavity before, right? And we're using the second derivative for concavity. All right, so let's, definition of concavity, the function f is differentiable and continuous. The graph of f is concave up. If f prime is increasing, but really we like f double prime is greater than 0. This is the same thing. F prime is increasing. We'll talk about that. F double prime is positive. Concave down. F prime is decreasing. F double prime is less than 0. Okay. So let's talk about this problem, and then we'll look at the increasing and decreasing piece. All right, we already did f prime because that's the one Emma Nunn just did for us. So let's put that up here. Okay, and since we're doing concavity, let's do f double prime. All right, what is it, Jenna? Okay, very good. All right, so if we're going to do this, we're going to first figure out, they call these the super critical points. when they're the zeros of the second derivative. Okay? 5 equals 6x, x equals 5, 6. Okay? 5, 6. Looking for F double prime.
Would it be negative?
Would it be negative? No. You're talking about x? No. Okay. Okay. So on the left of 5, 6, is F double prime positive or negative, Claire?
On the left?
On the left. So I get 0.
Negative.
Okay. And on the right, Cat, it would be. Okay. All right. So
Wait, why is it negative on the left?
when I put in 0 right here, 0 minus 5 is negative. Plugging into F double prime just like I did with increasing and decreasing. So F is concave up. Where? Kinsey?
5, 6, 7,
Okay, good. And F is concave down. Negative infinity to 5, 6. All right, let's get the graph going of F and make sure this makes sense. Just because it's okay. X to the third minus, I'm going to put 2.5 x squared minus 2x. Okay. What's the matter? Sure?
Yeah.
Okay. All right, there's your graph of x cubed. I don't think I'm cutting anything off. All right, if you want to find out where x to the 5, 6 is, you do second trace value 5, 6. Let's look at the concavity. It's right there. Okay, let's do that one instead. Now, there's your concave down, which we said that front part on the left is, and that's up. Okay. Now you could visually do that. You could find it pretty close, but you're not going to find 5, 6 without doing this mess. All right, now let's talk about, I'll show you, I don't like this, but let's talk about this function. Actually, go back over here. Okay, now let's talk about f prime. This is f, the function. Let's talk about f prime. Okay, what's f prime right here? Ish. Is it positive, negative? Positive. It's pretty steep, right? Okay, as we go around the bend, it gets less steep, and then it gets to 0, right? So we went from a pretty steep, positive, positive, then less positive, but still positive, and then we got to 0. And then what happened to it? It gets smaller, it gets negative. It starts out pretty steep and then comes around, gets to 0 again. Okay? All right, so let's talk about when we get to 5, 6. Okay? And this is this increasing. F is supposed to be, concave down. F is supposed to be decreasing. When we started out and we got to 0, and then we got to the negative, and then we started increasing it. So from here to here, F is decreasing, correct? Mm-hmm. So that's concave down. I don't like to use that, but you can use it depending on what your skill set is. I prefer the whole F double prime, but you can use F prime. I think it's increasing, though. Sometimes people want to think about positive, and increasing does not always mean positive, clearly. Yes?
Isn't that also the midpoint between the two? Like,
Yes-ish. Yes.
Coincidence, right?
I mean, it's the middle, if that's what switches, but you would have a hard time. I mean, what's midpoint as far as linear? I don't know that that's a linear midpoint. But it's in the middle, certainly, yes. But I don't know that you want to use a midpoint formula. All right. Okay, concavity changes at the point of inflection. You know about that, right? So what on this problem? Where was the point of inflection? 5, 6 is not a point. That's an X, but you're on the right track. Point of inflection, some people call it inflection point. Oh, look, it looks like a face. All right, but it definitely is at 5, 6. How did we find the other piece? Again, 5, 6 where, Hannah? That's right, the F of 5, 6. And we get it right here. 2.8, 82.824. The original problem, because that's what we're talking about. Rarely do we discuss concavity of F prime. That's just weird. You're talking about F. What do you know about F? Looking at F prime and F double prime. All right. Second derivative test. Which time do we have? Oh, yeah, this time. Okay. Second derivative test. Okay. F double prime is continuous near C. Okay. F prime of C is 0. F double prime is greater than has a local X. Okay. So this is a new function. So let's find F prime on our way to F double prime. All right. Holly, what's F prime?
3x squared minus 12.
And Jekyll, what's F double prime?
6x.
Okay. All right. So we're going to look at a different test. Okay. First of all, we're going to have to find the critical numbers. Okay. So what are the critical numbers of F prime equals 0 or F prime does not exist? None of these, right? 3x squared minus 12 equals 0. 3x squared equals 12. X squared equals 4. X equals what? Right, those minus 2. Those are my critical numbers. So that's the same as if we were doing now. If we were doing the first derivative test, we would interval test. Okay, we're not doing the first derivative test, we're doing the second derivative test. That's going to give us the same result. Okay, so we're going to find, since this was such an easy F double prime, the second derivative test is nice. We're going to find this, and we're going to find this. Okay? All we really care about is negative or positive, but we can do the whole thing. So if we plug in 2 to the F double prime, what do we get? Positive 12. Okay? If we put in negative 2, we get negative 12. The reason I'm focused on that is because that's what we're doing. Okay, now, if we know let me explain how this works. If we know the second derivative is positive, is F concave up or concave down? It's concave up. Okay. So, would this be a local max or a local min if it's concave up? Local min. That's your second derivative test. Okay? If we know the double prime is negative, it's concave down, right? Is this a local max or local min? Okay. It seems backwards because we have a negative and it's a max, but it's because of the concavity is why we have it. Okay, now, a lot of people will choose not to do that because we're all in the group of doing the interval testing and sometimes they'll force this, so be careful about that. You got to know it. All right, let's I feel like I'm rushing. Kind of feels like I am too. Okay.
It's just a lot of stuff.
It's just a lot of rerun. All right. So point of inflection. Tell me how I'm going to find the point of inflection, Miss Lizzie. Points of inflection, assuming there's more than one. But what am I going to do? Okay. Concavity or F double prime changes sign. Okay. She's just giving us time to slow down, right, Lizzie? Yeah. Okay. All right, so before we can find double prime, we got to find single prime. All right. So, Claire, give me F prime.
3x squared minus 12.
Did we just do this?
Yeah.
Okay. And that was this. And, okay, so how do we find where concavity changes? We're going from negative to positive, set it equal to 0. Very good. All right, so x equals, this is a possible inflection point. It's possible because we have to figure out if it changes signs, if f prime changes signs. And we just did that, did we not? No, we didn't do the interval testing. Okay, so we're checking this. Does f prime change at 0? I put in -1 and +1 over here on the right.
Yes, it does change.
Yes, it does, because it's going to be negative here and positive here, right? Did you have a question, Emma?
I thought you have been sorry to check that.
Now, for concavity of check F double prime. Increasing and decreasing, we check F prime. Okay? So, since F double prime is negative and then it's positive, what will then that point of inflection is at 0, what? Remember, it's the f function that we have to plug it into. So that's your -5. Okay? Ordered pair, point of inflection usually are an ordered pair, unlike sometimes we'll leave our max not as an ordered pair, we'll just write the tallest number that it is. Okay, any questions? All right, I think let's do it one with some trig.
Will you give us one before you leave it here? Or what it is?
Yes, I have it written down. We're good. Okay. Let's, we're looking for concavity and points of inflection. All right, so we want to find F prime and F double prime. You don't like what?
Don't like it.
Trig. Yeah, I hear that. That's, did y'all know Addie's folding?
Mm-hmm.
Last year she said, we did this big old long problem, she said, do you realize we didn't have any numbers in it? Oh, like, yeah. You realize that. So,
11.
all right, let's do. Okay, so we got F prime and F double prime, everybody? All right. What did you get for F prime, Kaylin? So next. And F double prime, Jacqueline. Nice. Okay. Now we are just going to worry about, so we don't have to keep going. Ouch. Keep going on and on and on. Sorry. So we are going to do concavity. So really, we're going to focus on him, right? All right. We got to do negative sine of x equals 0. I'm not going to use my calculator because my calculator is going to be ugly numbers. I want nice pi numbers. All right, so how do I solve that? Divide by -1. So sine of x equals 0. Inverse sine. So where's the sine 0 on your around about here? 0. Pi. 2 pi is included. Typically, it's not. But remember, when you go around the circle, you're not going anywhere up or down. That's where sine is 0. Good work. Okay, now we are looking for concavity where it changes. These are your supercritical points. So we're going to start at 0, end at 2 pi. In between, we're going to have a pi. So really, we only have 2 intervals to test. Okay? What's in between 0 and pi that would be nice to test into negative sine of x? Pi over 2 would be lovely because it's quadruple. It's easy to do. And what about here? 3 pi over 2, right? That's what you said. Okay. All right. Don't forget, we want to use this one, not this one. I mean, sorry, not that one.
If one goes numbers back in the double prime.
Yes, we're checking double prime for concavity. All right, so what's the negative? I'll just write it out here. Negative sine of pi over 2. Pi over 2 is right here. What's the sign? 1. So what's negative 1? That's negative. Okay. Sine of 3 pi, negative sine of 3 pi over 2. What's the sine of 3 pi over 2 down here? Negative 1, so that's positive. Okay. So concave up, concave down. We got that figured out. And point of inflection, we definitely have one. So F is concave up. Where? Pi and 2 pi. F is concave down between 0 and pi, where F double prime is negative. All right, inflection points at pi something, right? Is that the turning point? Right? Ordered pair. All right, and you got to put pi in somewhere. Where?
The original.
Right here. So f of pi is 3 plus sine of pi. Sine of pi is 0. There we go. Okay. Let me see what. So